Hi everyone, welcome to AP Calc back once more. I feel like it's been really long since I've seen AP Calculus. I don't know, I think it's because that spring break kind of added in like some more time. But welcome everyone, we are back. We are in day one. As a reminder, um, on Google Classroom, I've linked up today's slides. So feel free to go on there, make a copy on your own, and annotate it if you need it annotated. This is our first day here back, and welcome. So I'm letting in a few more folks. Our check-in question for today is did I wonder if I asked this already, but what is something that you always seem to lose is the question. I don't know if I asked this, but like for what I mean, for example, did I ask this? Can anyone tell me if I did? Because then whoops. Okay, good. Okay, so maybe I haven't asked this because that's a good one. Hair ties, yes. That is absolutely me as well. I have one right now in my pocket, but sometimes they disappear. And when I used to be in class, the thing that would disappear would be my special pen. If y'all remember, I had that pen that had different colors on it, and it would always get lost, and then I'd get stuck with having to use a wooden pencil. That would suck. All right, we got remote, pencils, phone. Oh, that sucks on the phone. Chapsticks, yep. Or there's always one chapstick that's just oops, I thought you meant chopsticks. Yeah, chapsticks, I agree. Mine would be the lip gloss that I'd be using. I thought you meant chopsticks. I always lose one of the chopsticks. Oh my gosh, AirPods. Ugh. Goodness forbid those get lost though. Those are expensive. My keys are phone. My AirPods, no cap, no matter how hard I try. That's horrible. Those are very small. I hope y'all found those AirPods though over time. I've known people who've just lost those. Socks are a good one. I always lose that other pair of the socks. And keys. Yeah. I'm like, I always have to have a special spot for the keys because then it's gonna get lost. Definitely. All right, let me go ahead and check who we have here. My bad. I was like so into reading all the responses that I wasn't, 100% formally checking who we have. Let's see. Okay, let's see. This is who I am missing. Okay, double check me if I'm wrong, but am I missing Sophia G? I'm trying to double check here in the yeah, I'm missing Sophia G. Sophia Guerrero Gonzalez. I'm also missing Israel. Let me know if you're here, Israel. I'm missing Kaylin, Evie, and Gracia. So let me know if you're actually here, but if you're friends with any of these folks, you can let them know to come on in. I know today is a funky, it's like we're starting a module on a Thursday. That's so weird. It's even weird for me. Like I said, I still even have to finish grading for the last module, so it's tough. But yeah, I'm glad y'all are here. Welcome to AP Calculus class. As you all know, I always be copying and pasting stuff, but let me just make sure I switch this. Welcome to our AP Calculus class. Yay. Okay, so here we go, everyone. Let us jump into what we're doing here today. So the other time, I told you all a little bit about my mastery experience when I went to UC Berkeley. I talked a little bit about how I had like my first like failing score, and I think I got like the lowest score in the whole class in my first math test there. I'm gonna kind of complete that story. And that's going to lead us into a Padlet where you offer some tips for any advice or tips for success. That's going to be our first Padlet participation. After that, we're going to go ahead and start to prepare for the unit with some consistent check-ins. The thing we're going to be talking about today is, well, y'all remember the derivative, hopefully, or you remember this word, derivative, always was coming up, right? Ugh. So we're going to actually talk about something called the antiderivative. After that, asynchronous number 6 was posted. This one is going to be due tomorrow's Friday, so Friday at midnight. first async. Your next async won't happen until next week. So does anyone have any questions about our agenda or anything that you see here up on this slide? Let me know before I move on. Okay, and if questions do come up, just let me know. Um, okay, everyone, let's go into it. So I'm gonna jump back into this experience that I had. So I shared a little bit of reminder. I shared that as a teen, I really struggled with like just in general my position in society, my impact, and everything seemed confusing. Except when I jumped into algebra class, everything just made sense. I really enjoyed the steps. But then I realized that in high school, I wasn't really prepared for college level thinking. Actually, I was more so prepared to memorize steps and give answers that probably teachers would like to hear, but it didn't really actually prepare me for my thoughts and the rigor that the college experience was. So I did hit a depression phase in college. Specifically, I received, I think, an 11 out of 50 in my first exam, 11 points out of 50 points in my first math exam over at Berkeley. And for me, that caused a whole identity crisis because all over in high school, I thought I was good in math. And for me, that was part of my identity. So it kind of shattered a bit of my identity when that had happened. Like, oh, I'm actually not good. But what I realized is I just didn't know how to study. So I actually learned how to study, as you can hit down here. I mean, if you see down here, hidden the books. So I had to kind of teach myself how to study once I hit college because I actually did not know how whatsoever when I was in high school. So where does that lead us into? And let me check out. Sorry, there's something in the chat. Oh yeah, it makes you feel better. Everyone's got a 10 out of 100 in tests they studied and passed the practice test on. Yeah, that's it happened. It actually consistently would now actually happen to me in college a lot, where I think I was prepared for a test, but I actually wasn't. So it's actually something I got used to, and it helped getting used to that because then I knew what I was doing wasn't actually working. But then thank you for that one, Rosa. That totally helps. But a lot of you and a lot of students were actually asking for me to kind of finish that story. So that's why I'm finishing it here. Like, what did you do? And in the end, why did I even decide to be a math teacher if I kind of went through that identity crisis? So over in university, once you all hit university, right, you actually rarely get to talk to the actual teacher. When you go there, the person that's going to actually help you, they're called the TAs. At UC Berkeley, they're called GSIs, graduate student instructor. Other schools, they call them TAs. Over like at UC Riverside, they're called TAs. So at every school, they're kind of called something else, but they're basically the teacher's helpers, and you rarely get to talk to the professor. So I went to my assigned TA, and for some reason, whatever they said just clicked in my mind. So I had told him, why was it that there was a time in class when the teacher or the professor had asked everyone a question, and I had no idea what the answer was, but everyone in class answered in unison. Like they're like, oh, they blah. And I was just like, okay, like I don't know where they got that. So I went to the TA and I said, can you like teach me how to be fast with this? Because everyone in class, did this in unison. And then he stopped me and said, like, well, no, it doesn't matter what other people are doing right now. You need to focus on yourself. And if you understand, no matter how long you take. And for me, that clicked because I'm like, wait, oh, so I realized that I was actually caught up with the competition of the space, like thinking I want to be faster than these other kids or I want to be faster than these other people in my classroom. But that wasn't the thing that's important for me. I mean, what was really important is that I'm actually understanding the class. And again, no matter how long I take, and it didn't matter if I am slower than the other people. So that is something that actually made me like kind of like click in my mind. And just that simple advice kind of helped me push forward. So one tip that I would offer, like just in case, y'all are seniors, so you will be heading to college soon, but and also tips for this module that could also help you. But what had happened when I was stuck and going through this crisis is I went through to a helpful resource, someone you trust. And for me, it was the office hours. So I was able to meet with the TA in their office hour during that time to kind of discuss that. And I was 100% honest. Like I was saying, like, oh, I'm struggling because I feel like I'm slow. But, they told me that that's not what matters. And I realized I was get caught up in that competition in the atmosphere. Um, I also noticed that my mindset was not focused on my growth and learning. So I kind of had to readjust my thinking. So my second piece of feedback for advice would be I had to interrupt my negative thoughts with positive ones. So I had to stop thinking I'm slow or that slow equals bad. There's actually nothing bad with taking your time and learning something. So I had to interrupt the negative thoughts. I'm like, hey, I take my time learning something. That should be a good thing. That should be a thing I should celebrate. Um, the next thing I had to learn, of course, in college is actually how to study. So I had to understand what I was doing and why. So that's when I had to kind of just go into the books and realize, well, how do I study? Everyone actually studies differently. What worked for me in college is I had to make myself little note cards. I had to write things down. I had to recite. I had to explain it to people. So there are different ways I kind of had to learn how to study, and it works differently for different people. Not one way is going to work for others. So I had to independently sense make and also join study groups, which you perhaps will have to do when you hit college, and you will always find a study group. I'll say that. I was a super shy student, and even I was able to find a study group of like-minded folks who also needed help. So it's completely 100% possible to still form study groups, even if you're like socially, intimidated or shy, because that was me 100%. I was a quiet student that sat in the back. So study groups did definitely help. Then lastly, of course, actually not lastly, this should be kind of at the beginning, but I had to remember my motivation. So a lot of why I was trying to be a math teacher specifically is because I wanted representation. Like when I grew up, I mostly had male white math teachers, and I wanted to be a Latina mathematician. So first off, female, and also I'm Mexican. I'm Mexican American, and I wanted to have that representation. So I had to set my mind on that goal and motivation. So setting and reaffirming my goals. So over here is kind of like the process of what I went through, and in red is kind of like the feedback and help and advice I would kind of give to myself back then. So those in red, and now what you all are gonna do on a Padlet is you're gonna try to put some advice you would give someone who's struggling with a mindset, or they're struggling anywhere and they're like kind of trying, right? Specifically, here's the question. What advice or tips would be helpful to you, to yourself, or someone else when they're struggling with a concept or a mindset? This is our first participation check, and it's going to be in the Padlet. So for those who are in the slide, it is slide 6. And for those who still need to get on the slide, here is the Padlet. Here we go. And I hope I am recording today, so awesome. So you're gonna go ahead and open up the Padlet, and we are on the first column. I don't know if you all are able to see the spinning windmill, but here, we're on the first column. So again, what advice or tips would be helpful to you? Like if you were to give yourself some advice, or to someone else, right? If they're struggling with a concept or a mindset, you're gonna put your name or initial here for today's credit. Let's have about 1 or 2 minutes, y'all, and we're gonna come back. All right, everyone, I went ahead and I set my little timer here. So time is up for the first column. If you're still writing it, go ahead and enter it. So we have a bunch of great advice here in the chat that could even help us for this module. And what I like is that it's going to be on this Padlet. So whenever we go onto it, you could look back at your own advice in case you are struggling, with a mindset, which happens, right? It's not something we overcome just once. Something that could also be a daily battle. So I really like it would take me a bit to just reach out and comment about all of this wonderful advice, but feel free y'all to just look through here. This is really great advice. I really like that a common theme is don't be afraid to ask questions, that people are there to support you, and keep going. It's going to be okay. And I like this one. It's better to ask for help than to just sit there being stuck, which feels pretty bad. It totally does feel pretty bad. Just to sit there, be stuck. But beautiful, beautiful advice, y'all. Awesome. We're going to go ahead and transition from that. I appreciate all that. And I can even see myself in my past, when I was about 20 and struggling in UC Berkeley, just looking at this and like seeing how it would totally have helped me to have seen this kind of advice too. So I appreciate it. All right, y'all. Let us go into the start of our unit. So as a reminder, please make sure that you go to Google Classroom, make a copy of today's slides, and follow along. All right. Preparing for Unit 4. So this is our unit. We are in quarter 4 as well, by the way. And an essential question that's going to lead us through this unit are how are rate graphs and something called accumulation graphs related? This essential question is going to lead us into actually the fundamental theorem of calculus. We don't know that yet, but don't worry. That's the whole unit's investigation. So just for the moment, just read this question and just kind of process it. And it's okay. Again, I know it's been a while since we've been in math class, so don't worry. We got this. All right, cool. Welcome if you just came in. I was updating the attendance. All right, so we are on our slides, slide 8, preparing for this unit. I'm going to transition us to slide 9. Now, before we prepare for the unit, let's refresh on the derivative. I don't know if y'all can hear. I moved and I live by a chicken and it always makes noise. I don't know if y'all can hear it. Oh yeah, by the way, I'm also missing Shannon. I was kind of just realizing that. So if anyone's friends with Shannon, let them know, could come into class. Okay, cool. So let's refresh in the derivative. So y'all remember the rule? This is the one where you bring the exponent down, multiply, subtract 1. Do you remember that? The power rule. I also went ahead and I put a screenshot of the last module's mini final, a screenshot of the piece of work. Y'all remember we're like in office hours and we're really digging into that one about the floor workers and keeping as many as possible. And we had to apply derivatives to kind of figure that out. So that's a little bit of a reminder of the derivative. And then further reminders is that the derivative is the slope of the tangent line to any function. Some definitions. The slope of the tangent line, what does that even give us? It gives us what's called the instantaneous or the instant rate of change of some object in motion. And there is this, if you're on the slides, you're able to click on this Desmos, but this kind of shows you what I mean. So in red right here, this red line is the tangent line. And where is that? Trying to see if A is not the slope. Oh, the slope I think is here in red. It would probably be the Y term, but basically this line is the tangent line, and as we move it, you see the slope and that red point is changing over time. So it's positive, really positive, negative. So this is just a little tool to kind of play around with if you're curious to remember like what a tangent line is, and finding the slope of this red line here is the derivative. So just a little visual reminder. Again, you have this tool that you could play around with. So notice that when it's negative, this red dot is below the x-axis, becomes 0 right here as it becomes flat. Then it becomes more and more positive. Yeah, so you can play around with it, but that's a little reminder if it helps to use that tool. The next thing is that power rule, the one I was kind of reciting with you here at the beginning, that is a shortcut used to determine the derivative of a function. So that's just a little bit of a refresher on the derivative and what we did in the last prior modules. Let me know if anyone has questions on that. Right after this, I'm going to quickly do a little review with you on like, hey, here's a function, let's find the derivative. And we're going to be utilizing this rule right here, the bringing down the exponent, subtracting by 1. Oh, okay. Thank you. So we're also, okay. Thank you. Welcome for those that just came in. Let me update the attendance right here. All right, cool. I appreciate it. Okay, so now let's jump into that example so we kind of just get our feet back into the dirt. I don't know what other way to express that. But anyways, let's just practice the power rule right now for the derivatives. Let's just review that because today's lesson is about the antiderivative, which sounds scary, but let's try it. Okay, everyone, let's review how to find the derivative. So remember the rule, bring down the exponent, subtract by 1. So the rule is kind of like this, like if you have x to the n for some power n, the rule is to take the derivative, you bring that n down, and then you subtract the exponent by 1. That's generally the power rule for finding the derivative. And we're going to go ahead and do that. So for this one, I'm going to bring the 4 down in front of the 5. When there is a number there, you have to multiply. So 5 times 4 is 20. And then we got to do 4 minus 1. That's going to be x to the 3rd. So that is the derivative of the first term right here. Then I'm going to bring down that minus. And we're going to do the same thing. We're going to bring down this 3 in front of the 10. 10 times 3 is 30. And we're going to subtract 1 from 3 to get x to the 2nd power. We're going to bring down that plus. Now this 2, we're going to bring that down. So it's going to be 4 times 2 is 8. And if we were to subtract 1 here, you would just get x to the 1st power. But we generally don't write the little 1st power, by the way, y'all. But you can if you want. It's not wrong, but it's just x. You could write the 1st power if you'd like, but again, no need. Oops, I'm just going to take it out. So it's just to the x. And I don't know if y'all remember, but the shortcut I use for this is the derivative of a linear function is just the constant in the front. So the derivative of negative 3x is just minus 3. And another rule that came from last module is that the derivative of a constant by itself, that means there's no x by it, is 0. So, I mean, you could essentially write plus 0 down here, but I mean, it doesn't really, plus 0 does nothing. So our answer or our derivative function is just this. Oops. So that is a little review on how to use that shortcut rule on finding the derivative of a function. And I just found the first derivative. I don't know, you all remember last module, we also did the second and we had to do like a sign chart. Right now, this is just reviewing the first derivative though. Just a very basic first derivative. And yes, oh, I just saw the chat. Yes, the 2x to the 3rd, that is right. Let's see, does anyone have any questions about this first example I just did? A little review on how to find the derivative using the power rule. So this is a little bit of review. I'll pause here to see if there's questions. All right, I don't see any questions, so I'm gonna go ahead and take that as a okay. Let's go ahead and move on. So again, this was review, and I'm reviewing this so that we can be comfortable with the new stuff. So let me clear my screen, y'all. Clear this up. Okay, cool. Let's go on to the next slide. The next slide is going to now after we did a little bit of review, now I'm gonna have us take a look at this essential question. The essential question, and you all have actually seen this screenshot before. I don't know if y'all remember, but in the beginning of the year, wow, when we first started distance learning, I gave you all this, and I asked you all to, like, in your groups, kind of discuss the connection between these two graphs. Perhaps you remember, perhaps you don't, but either way, I'm going to talk about this and kind of remind you. So how are rate graphs and accumulation graphs related? Right after I do this explanation, we're going to go on to the Padlet, and you're going to kind of rephrase your understanding in your own words. So be prepared for that. So I'm going to go ahead and talk about this connection. But first off, why? Okay, I was wondering why it's all green. I have to do this. There we go. Okay, let us talk about this connection that we actually already discovered in the first module. I'm just going to remind you all. So first, just making sure we understand the vocabulary. So rate graphs. A rate is basically whenever you have like something per something. In this case, miles per hour. That's a rate. We also actually, if y'all remember last year, like Rapunzel and the hair growth rate, that was a rate graph too. Y'all remember that one from last year? But this is a rate graph. So how are rate graphs and accumulation graphs related? Accumulation means something that's getting accumulated or added. So this is our accumulation, the distance in this case. Again, this is going to be the essential question. This connection between these two, rate graph and accumulation graph, is going to lead us into the fundamental theorem of calculus. It is the whole, you know, the whole reason of being, I guess. So let me show you the connection, y'all. I'm going to show you this, but later on, we're going to have a formal theorem because this is all something y'all investigated even in pre-calculus last year. But basically what it is that the area under a rate graph, if I was to shade up this area, and this is my rate graph right here, it was found that if we find the area of this here rectangle, what this is basically 3 times 50. The area of this here rectangle is 3 times 50, which is basically 150. That's the area, 150. Notice how this area correlates to the total accumulation in distance. 150 at the end of your 3-hour travel. So the area of my rate graph, let me just write that down, is the total accumulated distance. That's what I got right now. I'll put it right here because it's kind of hard. So that was actually something we looked at actually in pre-calculus, but a little bit of just reviewing right now. So the area is equal to the total accumulation. But there's another kind of way we could look at how this accumulation graph is also related to the rate graph. So there's a cyclical nature. Let's see what's in the chat. And then we have, oh, it's like 16.6 per hour. Oh, and then I don't there's like certain symbols after that, Rosa. I see like a question mark box and then a little, I don't know if that's a female symbol. I'm not sure, but yeah. 16.6, is it per hour? If you divide, oops. I'm not sure, but let's check that out. Oh, it's a female standing. Oh, that's why. I just see a little symbol with a box and a question mark. Oh, okay. Nice, nice. I think I haven't updated my Zoom, that's all. Now, what's interesting, y'all, is actually there is a connection for how this distance graph is related to its corresponding rate graph. Check it out. If I do the slope of this, so the slope is rise over run, right? So rise, and here's my run. So rise is 150, my rise, and my run was 3. So if I find the slope, which is rise over run, I'm going to put 150, that's my rise, and my run, I'm running over 3 in 3 hours. I get that my slope is equal to 50. And notice how 50 is the constant rate. So the slope gives me the rate. Over here, the area of the rate gave you the total distance. Here, the slope gives you the rate. Isn't that a crazy connection? Slope gives you the rate, the slope of the distance, which is accumulation, gives you the rate. So that is the cyclical connection that we're going to actually be investigating, or we're going to be formalizing. And it is actually, this is like a visual representation of the fundamental theorem of calculus, but we're going to be learning this in this unit. So by the end of the module, we'll understand it more. But that is the connection. Now, let me just repeat what I just said, because we're going to have a Padlet check about your understanding. So the area under the rate graph gives me the total accumulation, aka distance, but the slope of my distance or accumulation gives me my rate. That there is the cyclical nature happening here, and it's this important cyclical thing that we're going to be investigating in this unit and be able to develop some calculus with it. So super cool. Let me know, is there any questions before we jump into that Padlet check on your understanding about what was just said here in this visual? Let me just pause here. All right, y'all, I'm gonna go ahead and clear my screen. Don't worry, I think I am recording, so I will be sending out a recording, because I know these annotations aren't on your slide, but do give yourself a little note as you're annotating your slides about these truths. Yay, y'all, we got Kaylin with the K's. Okay, y'all, in your own words, I'd like you to go ahead and on the Padlet on column number 2, put down how you understand how are rate graphs related to accumulation graphs, or I put, or vice versa, how accumulation graphs are related to rate graphs. Like, what did you get from that? And it's okay if you didn't get much. Like, just honestly put what you understood from that. I'm gonna go ahead and also put the Padlet once more into the chat for those who aren't, on the slides with me. So there we go, y'all. This is our second participation check on the Padlet. Yes, let's go ahead and write that. Perfect. So I got a private direct message about it. Perfect. Go ahead and copy and paste that into the Padlet. The rest of us, let's have about a 1 or 2 minutes to go ahead and process what you understood about this connection between a rate and an accumulation graph, and how there's like kind of this weird cyclical connection to them. What you understood from that. Go ahead and put that down in the Padlet. Let's check in about 2 more minutes. Hey everybody, welcome back. It brings me great joy. I am seeing like a very deep understanding of this concept. So that's awesome. Do make sure I do see this wonderful comment here at the end. Do make sure you put in your initial or your name here for, oh, sorry, it's not the last comment, second to last comment, so that you can get your credit. I appreciate this. This is great. So if you understand this, you are understanding just the general idea of the fundamental theorem of calculus. Again, we'll know exactly what that is once we hit there. But let's go ahead and jump back into our slides. So that was awesome. And let us have a little intro on the antiderivative. It sounds like for me like an like a antidote or something. That's what I always think of. Like the derivative, but it's like something that like gets rid of the derivative. I don't know. So the antiderivative, our learning target is, sorry, sometimes I put a dash between it. I don't think you're supposed to, but the learning target is I can investigate and define what the antiderivative is here today. So that's what we're going to be taking a look at. And that's actually what your asynchronous that's due tomorrow midnight, that's what it's going to be about. But don't worry, I also included a little brief 5-minute Khan Academy like description on what it is, and then with one practice set. So it's a super short first assignment to get you some introduction on this. But this is what we're looking at, and this is what we're going to open up this new unit with. Okay, y'all, what is the antiderivative? Okay, so what it is this. Think of it as, let's say I'm trying to figure out like the derivative of what, question mark, is equal to 2x. So like I'm trying to figure out what is question mark. Or the derivative of what is going to give me 3x. Let's see. So let's just call this 1 and let's call this 2. I wonder if anyone knows if I was to fill in the blank. Remember, d dx means the derivative. So the derivative of blah gives me 2x. Or if you want to do the second one, the derivative of blah gives me 3x. Like, will we know how to replace or what question mark is? Let's see. All right, we have Sophia says x squared. Let's see if it works. And then I see the other one. How are you able to do exponents in the chat? That's amazing. Wait, can I try? I want to try it. X squared. See, this is what mine looks like, y'all. That's not fair. Y'all are really good. How come I see Sophia made it a perfect exponent? I think in my pre-calc class, I didn't know how to do pi. I would do this, pi. But then I think Francisco said, if you push option P, you get actually pi. Isn't that crazy? Oh, yours did it automatically. Okay. I'm like, some of you are really, really skilled in the how to type out this stuff. But okay, let's check the x squared one. So let's see. So let's see, for the first one, let's say the question mark is x squared. So let's check that. Is the derivative of x squared equal to 2x? Well, if I take the derivative of this, I know that I have to bring down this. Let me change my color. I know that I would have to bring down this 2 in the front and then subtract the exponent by 1. Let me do that right here. So I bring down the 2, subtract the exponent by 1. That would just give me x to the first power. Well, x to the first power is just x. I feel like this checks out. Do y'all agree? So the derivative of x squared is indeed equal to 2x. And Edgar's also putting that there in the chat as well. I feel like I agree. I feel like we have found something that replaces the question mark. Guess what? So Sophia and Edgar, those who put that there in the chat, what you have found was the antiderivative of 2x. You see how that works? You're trying to kind of figure out the derivative of something gives you an outcome. When you determine that something, that is your antiderivative. Our answer here, the antiderivative, question mark, the answer was x squared fits this blank. And this is the antiderivative. It's like you're going backwards, basically. Let's see, does anyone have any questions about how we have found the antiderivative for the first one? Let's see if there's questions. Okay. Okay, I don't see any questions, so I think we're set for the first one. So this is in general what an antiderivative is. You're kind of just figuring out like the derivative of what gives me this. Now let's try the second one. So I think I received x to the cubed, right, as a response as well. So I'm going to go ahead and change my color to blue. So one option was, let's say we're going to make this x to the third power. Would the derivative of that give me 3x is the question. Let's try it. Let's test this out. So we know to take the derivative is I got to bring down this exponent into the front, and then I have to subtract 1 for the exponent. So let's test it out. So I bring down the 3, and then 3 minus 1 is going to give me x squared. So unfortunately, I don't think I could force this anymore. It doesn't look like it's going to get me 3x. So that was a good check though, because I got the 3, but then the second part will not match up. So then this is almost there, but that was a good try. So, I wonder what something else we could try to put in here for question mark to figure out that antiderivative. Oh wait, that was the old one. We have 1.5 to the power of 2. Ooh, why aren't you doing this publicly? This is a private comment, y'all. Let's try that, y'all. So we just tried x to the third. It ended up not being the antiderivative. So let's try again. That's the beauty of math, y'all. Just trying something, trying again. Doesn't work. Let's do it once more. That was the whole college experience for me. So let's see. So I just received this in a private comment. Oh, and then we also have one from Sophia too. We also have one from Sophia. So can we let's try both of those? Can we? I think that perhaps I wonder if they'll work. I forgot decimals exist. Let's try both. So let me write them down both. So we have x squared plus x. And there was another someone who said this privately said 1.5 x to the second power. So here are two options. Let's test them both. So I'm going to first do this one. So I'm going to bring down this 2, subtract 1. When I do that, maybe I should have done it kind of down here. But let's do that. So I'm going to get 2x to the first power, which is just 2x. Then we have plus this x. Let's take the derivative of this. So plus x. X is actually a linear function. So if you all remember to take the derivative of this, you have to imagine that there's an imaginary 1 in front of the x. So the derivative of a linear function with just x is just going to be the constant in the front. So it's going to be plus 1. I just took the derivative of that second one. So this is what I got, y'all. 2x plus 1. Ooh, that one's close. That one was close. But it ended up not working. And again, that's the beauty of it. We just got to keep trying. Okay, let's try the second one. So that was this one. It ended up not working. Cool. Let's go ahead and erase it. Awesome attempt. And again, it's been a while since we've done derivatives, so y'all are doing really, really good for this. Let's try this one. Oops. Let's see if this works. So for this one, we're going to go ahead and bring down this 2 and put it in front of the 1.5. When it's in front of it, we got to multiply it. Then we're going to subtract by 1. So 2 times 1.5, y'all. Do y'all agree that that's going to give us a 3? Does it? You know, I'm horrible with decimals, but I believe it does. $1.5 times 2? Yeah, I got 3. I got 3. Okay, so far so good. We got the 3. Checkmate. Now we're going to go ahead and take care of this x. We're going to subtract 1. 2 minus 1 is just 1. And of course, we don't usually write that 1. So what we end up getting is just 3x. I think, ding, 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 we have found an antiderivative that gives us 3x. And this was shared with me privately, but I would have loved to, so we could give you some props on finding that. Amazing. So this one works. Okay. So the person who has found this was Rosa, y'all. Yay. That was amazing, Rosa. Wow. That was really, really good. Cause you know what? I would struggle with this. I'm really bad, like with the 1.5s, and wow, that is amazing. So we have found the antiderivative. We have found a question mark. And through trial and error, right? Through trial and error, we have found that the antiderivative in this case scenario is 1.5x squared. That is the antiderivative for this problem. Wow, that was really great. So let's see, are there questions about, just right now we're having an introduction about what an antiderivative is, and right now we're doing it with trial and error. There is going to be a rule that we can use. If you're curious, feel free to go ahead in the slides and check out what that rule is. That's awesome. And we'll be utilizing that rule from now on. But I mean, for now, try and get some practice on kind of looking at it in that way, where you're trying to figure out like what can go here that can give me the derivative of this. That is what the antiderivative is. Again, let me pause for questions. And if there are no questions, I'm going to take us into our checkout. We're going to get to learn that rule. It looks like we're going to have to learn that on Monday. Or you could take a preview, and that's also on your asynchronous actually. So you'll have some preview on that for that little rule. Okay, when we find the derivatives, like we get rid of the numbers with no x values attached, how will we go about finding any number values when determining the antiderivative? I think I understand your question. How do we get rid of? Are you talking about, like, for example, when you take the derivative of a constant and it like disappears, so you wouldn't know what was there before or something? Is that what you mean? I'm trying to think. Yeah, actually, I'm going to address that. Or if you're curious, you could take a look ahead on the slides. Yes, I was going to plan to address it today, but there's no time. And we're going to talk about what to do in that case scenario as well next week. Awesome question. And I'm surprised. Thank you for asking it. I had to really try hard to make sure I understood the question. Wow, it's really great though. Deep thinking right there. Okay, let me clear up the slide. And I'm going to take us into our checkout. Again, we didn't get to really cover the full things, right? That's okay. This is our first day and I don't want to overload us. Again, if you're curious, those questions y'all asked, check out the ahead slides, but we're going to continue this on Monday. If you're curious about the rule, it's on slide number 19. But let's go into our checkout. Our checkout today is, what is a question right now that's coming up for you about this new unit? I actually, let's say, Sophia, you already got the question. So that's Sophia's question. Like that question right there about what do we do when, a number disappears, and how would you find the antiderivative of that? That's a good question. That's a good checkout question. What other questions are coming up for everyone else about this module? And it could be about anything. It could be about the asynchronous. It could be about mini finals, whichever. Go ahead and use the chat there as our checkout. Oh my gosh. Oh, that's a good question. Will this be in the AP exam? Yes, antiderivatives are huge in the AP exam. Thanks for reminding me about the AP exam. I should be giving more announcements about that because I know that's happening in May. So yeah. A question I have is, when do we find the antiderivative? I think I already answered that. Is it in person? Oh, is the exam in person? No, I think it's going to be online. So AP exam will be online. It was online last year, and yeah, it's going to be online. So that means y'all have open resources. You're able to, like, look up resources. Is there a shortcut for antiderivatives or not? Yes, there's going to be a rule. And if you're curious about that rule, it's on slide number 19 of today's slides. I'm going to talk about it on Monday, though, as well. So I'll go over that shortcut. Good questions. What other questions are coming up for us here in this unit? Oh, ooh, okay. No, I don't think so. That's a good question, though. Are we going to solve for the antiderivative for the second derivative? Like, you know how you all had to do like first derivative, second, third in the first module? Yeah, I'm going to say H no. Like, heck no. We're not going to do double antiderivative. Great question, though. That would be horrible. How do we know when to find the antiderivative compared to the derivative? That is a great question. I feel like a lot of it has to do with that essential question picture I showed you. Like you have to know if you're looking at a rate graph or if you're looking at an accumulation. Like if you know to distinguish the two, then you'll know what you need. Hopefully that answers that question. But if not, we're going to figure it out throughout this unit though. I can't think of one. That's okay. No problem. Cool. Any last burning questions from anyone here in this group? It was an amazing class. Thank you so much, y'all. If there's any more burning questions, let me know. I'm happy to address them. But other than that, y'all have a great day. This was great. Yay. Bye, everyone. Enjoy. Bye, y'all. I'll try to upload this.